Hi everyone, Assalamualaikum. In this video, we will continue with applications of the chain rule, which is related rates. Now we look at example 5 from previous semester papers. At what rate is the volume of a box is changing if its length is 8 units and increasing at 3 units per second? Its width is 6 units and increasing at 2 units per second, and its height is 4 units and increasing at 1 unit per second. Okay, to solve this problem, first step, we write down all the information. Okay, at what rate is the volume? So we can write the volume over the time because we're talking about rate. Okay, and then equals to question mark. Its length is 8 units. So, we can write x equals to 8 units. Okay. Increasing at 3 units per second. Okay. Increasing at 3 units here refer to the length, means dx over dt equals to positive 3 units per second. We put positive here. We assume positive here because the word used is increasing. Okay. And then from units per second mean over the time. Okay. And then its width is 6 units. So we can write y equals to 6 units. Increasing at 2 units per second means dy over the time equals to positive 2 units per second because the word used here is increasing. And then height is 4 units. So we can write z equals to 4 units. Okay, or maybe we can write h equals to 4 units. And increasing at 1 units per second. Okay, so increasing means positive and then at 1 unit per second. So dz over the time, okay, equals to positive 1 unit per second. Alright. And then we can continue with step 2. Find del v over del x, del v over del y, and del v over del z and its value because v related with x, y, z. Okay. Alright. And then from volume of a box, so we can draw a switchable diagram. Okay. Let's say we have width equals to x and then length equals to x, width equals to y, and height equals to z. Okay, so from this diagram, we can write volume of a box v equals to x times y times z. Okay, and then from volume equals to x, y, z here. Okay, first we need to find del v over del x. Means we assume x as a variable. So to avoid error and easy to differentiate, we can put variable x at the back and we write in different colors. Okay. Alright. So from here, we can find del v over del x. Okay. Del v over del x means partial derivative of v with respect to x. We treat x as a variable and we treat y and z as constants. Okay. And then when we want to differentiate constant times x, we can imagine, let's say we want to differentiate 2x with respect to x. The answer equals to 2 and 2 here is constant. Means that when we differentiate constant x with respect to x, the answer equals to constant. Alright. And then we can replace y equals to 6 and z equals to 4. Okay. So we get 24. Okay. And then from volume equals to x, y, z here, now we want to find del v over del y. We done find del v over del x. So now we want to find del v over del y. So means that to find del v over del y, it is partial derivative of v with respect to y. Means we treat y as a variable. So to avoid error and easy to differentiate, we can put variable y at the back and we use the different colors. Okay. And at the same time, we treat x and z as a constant. Okay. And then to differentiate constant times y with respect to y, we can imagine, let's say we want to differentiate 2y with respect to y. The answer equals to 2, means constant 2. Okay, so when we want to differentiate constant times y, the answer equals to constant. Okay, means exact. Okay. Alright, and then we substitute x equals to 8 and z equals to 4. Okay, then we simplify, so we get 32. Okay, now we done find del v del x and del v del y. So after that, we need to find del v over del z. So we use from v equals to x, y, z. Okay, and del v over del z means partial derivative of v with respect to z. Means we treat z as a variable and we treat y, x and y as constant. Okay. And to avoid error and easy to differentiate, we can put variable z at the back and we use different color for z. Okay. And to differentiate constant z, we can imagine, let's say we want to differentiate 2z with respect to z. The answer equals to 2. 2 here means constant. So means that when we want to differentiate constant z, the answer equals to constant, which is xy. Okay. So now we find del v over del z. Okay, then we need to replace x equals to 8 and y equals to 6. Then we simplify, we get 48. So now we done find the value of del v over del x, del v over del y, and del v over del z. Okay. Alright, from the previous slide, we done step 1, write down all the information here. And step 2, we done find the values of del v over del x, del v over del y, and del v over del z. Then we can continue with step 3, set up the chain rule formula. Okay, from here we want to find dv over dt. So to set up the formula of chain rule, okay, if there are 3 variables, let's say x, y, and z, the chain rule will have 3 pairs of multiplication of 2 derivatives. Okay, between 3 pairs here, okay, is a plus sign. Okay, and then we have variable x, y, and z here. So we have del x, dx del x, dy del y, dz del z. Okay. Alright. So we just imagine, let's say we can simplify dz del dx del z del x here, dy del y, and dz del z here. Okay, let's say we imagine we can simplify. So we will get back del v del t plus del v del t plus del v del t. And it's equals to dv over dt. Okay, this is chain rule. Okay, if we have 3 variables, let's say x, y, and z, the chain rule will have 3 pairs. Okay, 1, 2, 3. Okay, 3 pairs multiplication of 2 derivatives. Okay, between 3 pairs of multiplication of 2 derivatives is a plus sign. Okay, that's how we set up the chain rule formula. Alright, and then dv over dt equals to del v over del x. Okay, we replace by 24 here. Okay, dx over dt we replace by 3 here. And then del v over del y we replace by 32 here. And then dy over dt, we replace by 2 here. And then plus del v over del z, we replace by 48 here. And dz over dt, we replace by 1 here. Okay. And after that, we simplify. So we get dv over dt equals to 184. And then because this is volume, so the unit is units cube. And then per second because we have over the time here. Okay. Means that the volume. Okay. At what rate is the volume? So means that the volume of a box is increasing because we have positive sign here. The volume of a box is increasing at the rate of 184 units cube per second. So this is the final answer. Right? Coming up next, more examples for applications of chain rule. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.